Alright, and here is a different type of example. And in this example, what it says here is that we're going to find the coordinates of the point at radius 12 from the origin and an angle of 5 pi over 6 from the positive x-axis. So a lot of information going on here, but I would like to track this down a little bit one by one. So allow me to highlight a few information here. But first, we want to find the coordinates of the point at radius 12 from the origin. If we're looking over into my working board here, being a radius 12, let's pretend that we're at some point here on the xy coordinates plane right there, and that radius 12 means from the point we're at right there. If we draw that segment that connects between the origin and that point itself, it's going to make a radius 12. That's what it means right there. And I am not saying that this is the picture of our current problem. I'm just demonstrating what it means. By a lot of time, commonly when you say there's a point in the coordinates plane and that's making a radius 12 with the origin, that's what it is. That distance from the origin out to that, or the length of that segment connecting between the origin and the point itself. And the next piece of information we can make good use of is that this point here is making an angle of being an angle of 5 pi over 6, but in further information from the positive x-axis. And so straight out from that, directly out or straight out from that description right there, then that means it says from the positive x-axis, the positive x-axis is here, and then making an angle of 5 pi over 6. And so that means it's just the usual 5 pi over 6 in a positive direction. So my angle has to be, it's about a 30-degree angle there. And so the point needs to be, the terminal point or the angle itself needs to land into somewhere in quadrant 2. This is about a 5 pi over 6 is. And so that's what it says right here. Make an angle from the positive x-axis to be a 5 pi over 6 angle. And so now that terminal point of us here is now known to be at radius 12, combining with the other information that we've looked at earlier. And so that's the point that we need to look for, which coordinates x, y can it be. And so here, since it's looking into that description of angle being 5 pi over 6 from the positive x-axis, now let me also introduce another term that quite often used out there as well. But the angle like this, where it made a rotation, the angle like this created by a coordinates point, and the way we see that here is that it was a rotation, a positive rotation from the positive x-axis. So that type of angle, a lot of time for short, to save, it's all about to save ourselves from the long, lengthy description. And so we're going to refer to that kind of angle right there. I'm going to say that the angle is in the angle, it's the angle in standard position. All right, so now getting ready for this work right here, we need to recall from our understanding from the lecture that what we need to realize here is that this coordinates point we're at is now no longer on the unit circle. It's radius 12. So radius 12 or equals 12. And so, but we still in the end having some kind of circle with radius 12. Or equals 12 for that radius. And so in that way, once we know that we're no longer in the unit circle, I need to remind everybody that when you're not any longer on the unit circle, then your cosine of the angle theta is defined or is related with the coordinates as x over radius r. And then the sine value of the angle theta is the y coordinates divided by the radius. And so right out from these two relationships, we also learned that consequently x coordinates now can be found simply by doing multiplying that r, that radius, to cosine theta. So radius times cosine theta. That allows us to come up with x coordinates of any point on the plane. And then the y value can be found similarly. Multiply the radius value with the sine value of your angle theta, the central angle theta. And so this is what we are going to apply into solving our problem here to find the coordinates. And so the answer is almost here. The x coordinates for my terminal point here now is going to be simply radius 12 as given, multiplied with cosine of the angle 5 pi over 6. And that was the angle it made with the positive x-axis. And so what we're looking at now is going to be 12 times square root 3 over 2. And so that gives me my final answer as being, and 12 cancels with 2. So we're looking at 6 square root 3. And that's my x value, or my x coordinates of that designated point there. And so very similar argument. Then the y coordinates of that terminal point is going to be found by using that quick little formula. And so what I can do here is going to be 12 multiplied with the sine value of the angle 5 pi over 6. And that gives me, so y equals 12 times, and it's going to be 1/2. And so it is now canceling out a 12, cancel with 2, gives me a 6, and I got a positive 6. So in that way, concluding our problem here is now that the coordinates pair of that terminal point must be 6 square root 3 comma 6. All right, so in a different example, what we have here is now we're going to need to find the angle theta being the central angle, but in standard position. And just earlier, in a different example, I was explaining what standard position means. And so here, let theta be the central angle in standard position of the points 3, 4. So what we have here is the coordinates pair of of that terminal point giving me this angle, and then the term here is being in standard position again. And then there's your x and y coordinates pair. So what we need here is actually to find sine of the angle theta. And so let's now look over to my board right here. But the idea now is that, and by the way, having a coordinates pair is making it a lot easier than tracking down angle. And so 3, 4. So let's say based on scale 3 is about here, 4. So we have a coordinates point about right there. This is the coordinates point 3, 4. And so that terminal point, now treating that as a terminal point on a unit circle, then we're going to have a distance from the radius, from the origin, So that distance there is going to make some radius. Now notice we haven't had the radius information for this kind of problem right here. But we know now that the standard, the angle theta in standard positions refers to this angle. And so now, learning from and having some experience through the previous example, then recall that x is equal to r times cosine theta, and y equals r times sine theta. And so what we ultimately need here is that cosine theta can indeed turns out equals x over r, and sine theta indeed turns out to be y over r. And so for this particular example, it is more useful that we use these two forms here, even though they are equivalent. And so what we actually need to find before we can get into using the formula is we need to find out what the radius here is. So radius from any point. So let's say you have a point P, x and y in the coordinates plane. And so any radius from the center, from the origin out to the terminal point right there, then the radius there is always going to imply a radius being the square root, and it's a positive square root due to actual distance. So coordinates x coordinate square plus y coordinate square inside the square root, and that's how we find the radius of any coordinated point on the x and y coordinates plane. And so for this point being 3, 4, the point being 3, 4, and it implies that we're going to have a radius being square root of, so inside the square root I'm going to have 3 square plus 4 in parentheses square, and that will produce for me it's a square root of 9 plus 16. It turns out being 5. Since 9 plus 16 is a 25, and inside the square root it's overall 5. So here's our radius, and so now we are actually ready to find the sine of the angle theta, the sine value. The sine value of the angle theta is simply just the y coordinates. So the y coordinates in this case, or let me repeat the formula one more time. Y coordinates over the radius, and so in this case we're looking at 4 over that radius being 5. And so now concluding our work here for this problem, the answer is sine of theta must be 4 over 5.